All right, in this video, we're going to go over complex numbers part 2. Our cue for this is how do I multiply and divide complex numbers, and how do I factor complex equations. All right, you got one vocab word for this unit, complex conjugates. There are number pairs that form a plus bi and a minus bi. Now, something else that you might want to note. When I ask you to take the complex conjugate of a number, if you notice here, the only thing you do is flip the sign of the imaginary part. All right? You just flip the sign on the imaginary part. That's all you do to find a complex conjugate. So when you're given an imaginary number, you take the complex part and you change the sign. If it's a plus bi, you change it to a minus bi. If it's already a minus bi, you'll change it to a plus bi. The numbers themselves won't change, just the sign on the imaginary part is all that will change. All right, multiplying complex numbers. What is the product of each? Now, with adding and subtracting complex numbers, you could only add together the real parts and add together the imaginary parts. All right, but here, when you're multiplying complex numbers, you do it just like you would multiply if this was 3x times the quantity of negative 5 plus 2x. You would still multiply each number by 3i. You do the same thing with imaginary numbers. So we're just going to distribute the 3i through the parentheses. We're going to get negative 15i plus 3 times 2 is 6. I times I is I squared. Now, the only difference here is I squared, I don't know why I made that a t. The only difference here is I squared equals negative 1. All right, so since we know I squared equals negative 1, we need to simplify this down a little bit. So we're going to have negative 15i plus 6 times negative 1. So I took the I squared, since I know it equals negative 1. I took the I squared and replaced it with negative 1. So now, 6 times negative 1 is negative 6. So negative 15i minus 6. Now, we need to write this in the reverse order, negative 6 minus 15i, because it's always got to be in the form of a plus or minus bi. All right? Your real term will always be first. Your imaginary term will always be second. All right? Now let's do this one. We just FOIL it. So that would be negative 4. That would be negative 8i minus 3i. And then that would be minus 6i squared. This here is negative 11i minus 4. Now again, we got to replace this I squared with a negative 1. All right, so this here will become a plus 6 minus 11i, and then a negative 4. So 6 minus 4 is 2, and then of course they're minus 11i. All right, so when you're multiplying complex numbers, like the first example, you're simply going to distribute the 3i through, and anytime you get I to a power, like here we got I squared is negative 1, so you got to put in the negative 1. So that's where we get the negative 6 from, and then of course the negative 6 has to be first because that's the real term of the imaginary number. When you have two quantities like this, you simply FOIL them together, just like you would if they were x's. You'd simply FOIL them together, combine your like terms, and where you have I squared, replace it with negative 1, and then finish simplifying. Now, I will tell you this. If you write I1, kind of like you're playing a game and you're like, I won, you know, you're excited. I won, and your negatives are in the middle. All right, if you remember that, you'll always remember this is I to the first, this is I squared, this is I cubed, and this is I to the fourth. All right, so I won, negatives are in the middle, and that's I to the first, I squared, I cubed, and I to the fourth. All right, if you remember this chart, when you're doing complex numbers, right? If you remember this chart, when you're doing complex numbers, you'll be able to easily and quickly simplify when you have I raised to an exponent. Because I cubed, you'd need to replace it with a negative I to the fourth, you'd need to replace it with 1. Things like that, all right? So make sure you write that down. All right, I want you to try these 3 real quick. What is the product of each? So go ahead and pause the video and work them out. All right, letter A, just multiply these together. 7 times 3 is 21. I times I is I squared. Well, if you remember, I squared is negative 1, so this is 21 times negative 1, which is negative 21. All right, here, you got to fold them together. So that'd be 8 plus 10I. What is that? Minus 12I minus 15I squared. So I squared is negative 1 times negative 15. This go down to negative 2I and then 8. So this here is going to be 8 minus 2I plus 15. So 15 and 8 is 23 minus 2I. So that's what you should have got for the second one. And then the third one here, that's positive 16, I'm sorry. That is positive 20I. That is negative 20I. And this is negative 25I squared. These cancel. This becomes 16 plus 25, which is 41. Because remember, that's negative 1, so negative times negative is positive 25. Bring down the 16, the 20s cancel. So your final answer there is 41. All right? That's all there is to multiplying. You just simply multiply each term by each term, just like you do when you have x's in this case. All right, but what about dividing complex numbers? What is the quotient of each? Now, this is where those complex conjugates come into play. All right, that was your vocab word, complex conjugate. Now, this is where you're actually going to use the complex conjugate. All right, remember what I said? All you do is change the sign on your imaginary term. So if you look here, let's look at A. We have 9 plus 12i divided by 3i. All right, so what we're going to do is we're going to just change the term of the imaginary term. We're going to change the sign of the imaginary term of the denominator only. So 3i would go to negative 3i. Now what we're going to do is we're going to multiply the top and the bottom by that complex conjugate. So we're going to multiply the bottom by negative 3i. We're going to multiply the top by negative 3i. All right. So now just distribute it through. That's going to be negative 27i minus 36i squared. And down here, we're going to get negative 9i squared. All right. All I did was multiply. All right. You take your complex conjugate, which you just take your bottom number, okay, your bottom imaginary number, change the sign on the imaginary term, and then multiply the top and bottom by that new term. All right. So this is what we get. Well, we know this here is negative 1. Same thing down here. We know this is negative 1. So negative 36 times negative 1 is positive 36. And of course, nothing happens to the negative 27i. And then negative 9 times negative 1 is 9. All right, so your final answer, actually it's not a final answer yet because we can still divide, but we're going to have 36 minus 27i over 9. Now, everything here is divisible by 9, right? 36 divided by 9 is 4. 27 divided by 9 is 3. And of course, that was a negative. So your final answer for this one is 4 minus 3i because it will reduce. All right? Because it will reduce. So that is our final answer. All right? So keep in mind, watch out for that. Because if you left me this on a test, I'd take off a point or so because you didn't reduce it down. Okay? So let's look at this one. We're going to do the same thing. We're going to multiply the top and bottom by the conjugate of the bottom. So all you do is you change the sign on the imaginary terms. So this is going to be 1 plus 4i and 1 plus 4i. All right, now you just multiply together. I'm not going to draw all the lines, but you're going to get 2 plus 8i plus 3i plus 12i squared over 1 plus 4i minus 4i minus 16i squared. That's what you should get when you FOIL the top together and then you FOIL the bottom together. These cancel. All right, and the top you get 2 plus 11i plus 12i squared. And the bottom you get 1 minus 16i squared. Remember, I squareds are negative ones. So this becomes a negative 12. Negative 12 plus 2 is negative 10 plus 11i. And then this becomes positive 16. Positive 16 plus 1 is 17. So your answer is negative 10 plus 11i divided by 17. All right, so when you divide complex numbers, you have to get the complex conjugate of the denominator and then multiply that by both the numerator and the denominator. The reason we do this is because if you notice in our denominator for both of these problems, it gets rid of i's. There's no imaginary number left in your denominator. So when you multiply by the complex conjugate like that, you will not be left with an I, the imaginary unit I. So therefore, your denominators will always be an integer. All right. At the first example, it was 9. Yes, it divided through to give us just a 4 minus 3i, but I'm going to say the denominator in A was 9. We got rid of our I there. For letter B, our denominator was 17. We got rid of our I there. Because just like you can't have a radical in the denominator, you can't have I in the denominator either. And the way to get rid of it is to multiply the top and bottom by the complex conjugate of the bottom. All right. Let's try these two real quick. All right, so your complex conjugate here, we're going to multiply by 3 minus 4i, whoops, and 3 minus 4i. And then over here, we're going to multiply by minus 6i and negative 6i. All right, so this one, we're going to get 15 minus 6i minus 20i plus 8i squared over 9. Well, it's just going to be 9 minus 16i squared. So this, let's go up here now. We're going to have 15 minus 26i plus 8i squared over, we know this is negative 1, so this is positive. So that's 25, negative 1, so this is negative 8. And 15 minus 8 is, what, 7? So this is going to be 7 minus 26i divided by 25. All right, so there's your final answer for that one. This one over here, we're going to have negative 24 minus plus 6i squared, oops, 24i, over negative 36i squared. So we know this is negative 1, this is negative 1. So we know this is going to be over 36, and this is going to be minus 6 minus 24i. You can pull a 6 out of everything. So you pull a 6 out of here, you're left with negative 1. Pull a 6 out of here, you're left with negative 4i. Pull a 6 out of the bottom, you're left with 6. All right, so your answer is negative 1 minus 4i divided by 6. All right, so that's all you do for dividing. You multiply the top and the bottom by the complex conjugate of the bottom. To find the complex conjugate, you just take your imaginary term and you change the sign. So like for letter A, we had 3 plus 4i. We took our imaginary term, changed the sign, got 3 minus 4i, multiplied the top and the bottom by 3 minus 4i. With letter B, we only had our imaginary term, which was 6i. So we just changed that to negative 6i, and you multiply the top and the bottom by negative 6i. All right, and that's all there is to dividing. All right, last thing we're going to go over is factoring using complex conjugates. Actually, this isn't the last thing. There's one more thing after this. I'm sorry. Factoring complex conjugates. All right. So the first thing we need to do here is factor out the greatest common factor. So what's the largest number that you can take out of 2 and out of 32? All right, well, 2 is the answer. So factor out of 2. 2, we have x squared. Factor out of 2 here, we have plus 16. All right, so that 2 is going to hang out for a little bit. Now, if this was a minus right here, this would factor into x minus 4 and x plus 4. Yeah, that's right. Never mind. All right. It factor into x minus 4 and x plus 4. But it's not a minus, okay? It's a positive. It's not a minus, it's a positive. Which means when we multiply this together, okay, when you take x minus 4 times x plus 4, you're going to get x squared minus 16, right? We're not going to get the plus. Well, if we had an I here and an I here, all right? So we have it. So now let's throw our 2 i's in right here. This would give us 16i squared, which I squared is negative 1, and then negative 1 times the negative 16 is where the positive 16 comes from. So I said all that to say this. When you see x squared plus a perfect square, all right, 16 is a perfect square. What you're going to do, you're going to factor that perfect square. 16 factors, and I mean, you're going to take the square root of that perfect square, 4 and 4. Okay, you're going to have 1 plus and 1 minus, and then you're also going to have the i's. All right, so I'm going to write this in terms of if this was a squared plus b squared, this would factor into a plus bi and a minus bi. All right, because it's not x squared minus 16, it's x squared plus 16. So the only way to get that plus is to multiply a negative and a negative together, or a positive and a positive together, unless you use the imaginary I, because then that'll give you the negative 1, which will then flip it to the plus 16. All right, so when you factor using complex conjugates like this, all right, it's going to factor into x minus the square root of this number times I, and x plus the square root of this number times I. All right, that's how you factor using complex conjugates. All right, I want you to try these two real quick. All right, this one here, you pull out the 5, you get x squared plus 4. So you're going to get 5, x minus the square root of 4 is 2i, and then x plus 2i. All right, and that will be your final answer for this one. 5 and then x minus 2i times x plus 2i. It doesn't matter if this was the plus and this is the minus, as long as you got one of each. Now this one here, we don't have to pull out a greatest common factor, so we can just go ahead and factor this one. We have x plus square root of 81 is 9i, don't forget the I, and x minus 9i. And that's it for factoring. When you get x squared plus a perfect square, x squared plus a perfect square, it's x plus the square root times I and x minus the square root times I. And that's it for factoring. All right, I know this video is getting kind of long. I got one more quick thing to go over, which is finding imaginary solutions. Basically what this does is you use the quadratic formula and your discriminant is going to come out to be a negative number. So therefore, you're going to get complex solutions. Let me show you. All right, I know you know the quadratic formula. So this is going to be x it's going to be a plus 3 plus or minus the square root of negative 3 squared minus 4 times 2 times 5, all divided by 4. Okay, all I did was fill into the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac divided by 2a. All right, I'm trying to do it quicker because we're running out of time. So this will give us 3 plus or minus the square root of 9 minus 40 divided by 4. Well, 9 minus 40 gives us a negative number. All right, that gives us negative 31. Well, we can't take square root of a negative number, right? Unless you're using I. When you're using I, you can take the square root of a negative number. Now, we would not leave it like this. Since we have the square root of the negative, you would need to pull out the I. Okay? You would need to pull out the I. So this would be 3 plus or minus I times the square root of 31 over 4. All right, sometimes you'll see these split up into two separate fractions, meaning 3/4 plus or minus the square root of 31 over 4, and then an I out here. Just recognize that these are the same exact thing, okay? All they did to get from here to here was they just split it into two fractions, all right? Which is fine, you can do that if you want, but you can also leave it like this, doesn't matter to me. All right, so finding imaginary solutions. When they're not factorable and you have to use the quadratic formula, you still do it the same exact way. Just remember, you will be pulling out an I if this becomes a negative number like it was here. You will pull that out and you will have I in your final answer. Okay? So that's the only difference for part 2 of complex numbers. That's the only difference to the quadratic formula when you're finding imaginary solutions is you will end up taking the square root of a negative number and you will have to pull out an I along with any factoring that you can do underneath the radical, okay? All right, I know this video has been a bit long. That's been your complex numbers part 2. Feel free to watch this as many times as you need to. Make sure you understand the concepts and come tomorrow ready to work some problems. See you tomorrow.